today is to really share in the great news that Markforged just announced last week about the two new industrial 3D printers that they added to their composite lineup. It is the X3 and the X5. Now, with these new additions, Markforged is now really the only company that offers an industrial 3D printing basically line that incorporates the software, the hardware, the strong materials like their composites and the metal, and it's all designed to provide a seamless experience to their users. But before we dive into a lot of these new developments, we'd like to give a brief overview of what Markforged is all about for those of you that are maybe new to 3D printing and this industry. And if you're not yet a DesignPoint customer, I'd like to give a quick rundown of how we really impact our customers. So having a little trouble with my slides here, so give me a quick second. All right, there we go. We're up and running now. So really in short, DesignPoint, we love everything 3D. We're extremely passionate about building solutions that help, product design, engineering, and manufacturing companies really maximize their potential. So through our relationships with SolidWorks, who provide the best 3D design products in the industry, to our partnerships with 3D printing companies, just like, Alex's and Markforged. They produce really high-end, strong parts. We also partner with 3D Systems. They're known for making, really superb, high-resolution finished parts. Our customers accomplish really great results with these products, and we make sure that you guys are going to use these tools effectively to transform your business. And we only carry the best products, and we hire the best people to provide you with some fanatical service. We believe more is possible with every company we work with, and we're going to actively engage your team at all levels to ensure that you guys really have success here. And at the end of the day, you will accomplish or exceed the results that you guys are looking for. So let's talk about a really unique company, and that's Markforged. So Markforged approached DesignPoint last year and made some pretty bold statements. One, that every one of our customers is going to own or have access to one of our 3D printers. Now, having been in this industry for over 20 years now, DesignPoint, and seeing the up and down roller coaster ride of the 3D printing world, I'm sure you could imagine that we were a little skeptical. However, Markforged has more than proved that their technology is the holy grail of 3D printing. And we, DesignPoint, we are 100% invested in Markforged, and we believe that they have an amazing future. Now, with these new additions that we're going to talk about in a minute to their industrial lineup, there is no doubt that there is going to be a fit for one of these printers at every manufacturing and engineering company. And it's our job to prove that to you guys today. So I guess, why do we believe that? What makes this the holy grail of 3D printing? Simple. Strong parts. As local manufacturers, you guys have been in the past at a little bit of a disadvantage because you're forced to choose between subpar strength of a 3D printed part and then the long lead times and cost associated with the alternative, which is a machine part. How many of you guys have wrote off 3D printing in the past because it couldn't produce something that could withstand your work environment, or maybe it was just way too costly? I would assume probably a majority. So Greg Mark, who is actually the founder of Markforged, and he's also an aerospace engineer graduate from MIT, he patented a very unique 3D printing technique by layering in continuous strands of fiber material to their own filament, which is basically a chopped up carbon fiber nylon blend, and they call this Onyx. It's a really cool name for something that is 2 times stronger right out of the gates than ABS. And ABS, if you're not familiar, is it's a very common thermoplastic that's used in a lot of FDM machines nowadays for modeling and prototypes. So Our product, the onyx material, as you see by this graph, is again 2 times stronger than that type of material plastic. So what you're going to get as you continue to learn the technology and take advantage of that, which is adding fiber content, you're going to get a part that's roughly 19 to 24 times stronger than that ABS material. And that's going to be dependent on the fiber that you're going to be using. So if you're not familiar with Markforged, here's a quick breakdown of all the fiber material you can run through their machines. Carbon fiber being, really the most popular because it's very ultra lightweight and strong. So you're using it in a majority of the applications, the drone industry, robotics, fixturing, jigs, things along those lines. Kevlar is also great. It's a yellow material. It's used for high impact resistant, applications. I have a lot of our customers use it for different guides, on some of their machines. And even fiberglass, you can add that if you need something that needs a heat reflection of almost 150 C. So again, there's a lot of material that you can end up running through this machine. It's also going to give you a much higher strength ratio than just using the onyx. And again, we're going to get into why you would do that here in a minute. So in the end, we're really talking about a plastic part that could be comparable, and I think in some cases even stronger than metal. So here's how they do it. They have actually a secondary nozzle that's paired right next to the filament nozzle, which is going to layer in that fiber on a specific area of your build, and that's going to optimize your real strength there. And the great thing about it is that you really only have to press a button. A lot of what's happening behind the scenes is with the software. It's really doing a lot of the work for you. It's slicing your STL file, which is what file part it actually accepts. And then it's also adding in support layers where necessary. It's even going to give you recommendations on where to add fiber based upon your part's geometry. And in the same time, it's going to calculate your ROI data, which it could be, estimated time, material cost, weight, and things along those lines. So I also have a lot of companies ask that, okay, well, great, you're making an ultra hard part. It's going to be really strong, but that probably means I have to compromise on something else like accuracy or resolution, right? No, the surface finish with this material is unmatched by any other FDM comparison out there. I mean, we're getting parts that are, 50 micron layers or 0.002 of an inch. And the accuracy is phenomenal as well at, plus or minus 125 microns, based upon parts geometry. I mean, you can get almost down to plus or minus 50 in certain applications. I do a lot of demos on a regular basis for businesses, and we also print a lot of sample parts. I mean, I've had customers tell me that this, some parts that come off these machines resemble something off of an SLA machine rather than an FDM. It's that quality of part. You can very finely, I mean, almost with a microscope, you can see the contouring lines. So when we look back, you think about, strength, time, accuracy, resolution, affordability. I mean, these were all things that would have to be trade-offs in this industry, but, no longer. You guys can get same-day parts that optimize strength and are super affordable with one of these machines. So obviously, and parts of this nature of the uniqueness of the technology, Markforged is no longer a secret. They took their product global and really had a widespread adoption across all verticals. They are the go-to resource for producing strong 3D printed parts. Now, companies are building stronger parts at a rate of 50 times compared to traditional manufacturing, on a CNC machine, which means, you can, slash critical lead times. You can ship product to market much quicker. And guess what? You're also going to cut your expenses by upwards of 20 times. So all in all, you're going to increase your productivity by saving on engineering time and just overall effort. So here's a short list of just a few, big name companies that are finding success with Markforged. Companies like NASA, Google, Ford, Amazon, General Electric, and thousands of other countries and 50 countries are using Markforged to print same-day prototypes and produce strong end-use parts. But what you'll notice is that it's not just one type of industry that are using these machines. It's an array of different businesses that engineer all types of products. And I know the majority of industries that we work with, that we service, are like machine design shops, tool, die, and mold companies, black box companies for like electronics, medical devices, and even, consumer products. And I'll say it again, there is a place for one of these machines in each of those industries. They do, however, have one, real common thing in their applications. They really fall into three categories, I'd say. You have prototyping, which are your more traditional use cases for 3D printing, but now allow you to test fit, form, and functionality. And then end-use parts, which until now could never survive the harsh manufacturing environments or certifications you would need in the automotive, aerospace, or even medical industries. But the real focus on Markforged, I think it comes down to the manufacturing of tooling, like jigs, soft jaws, robotic grippers, and again, all of the different fixturing applications. Tooling, I believe, is the no-brainer application for this technology. And I know with our customers, we've seen the shortest ROI at only 1 to 3 months of even owning a machine. So with that being said, let's talk more about the tooling aspect. Why is it such a great application? Because with tooling, you're making only a few of each part. Maybe you're probably changing these parts quite frequently, and you need quick turnarounds, right, to ensure timely delivery. And in most cases, you're making a tool is probably pretty expensive and maybe even requires a lot of engineering time. So all in all, tooling is kind of a pain. Lead times are incredibly long, and productivity just stops when things break down. With Markforged, you're replacing the old design to end part in maybe 6 weeks to design to end part in 1 day, maybe even hours. Tooling is also really expensive. Parts cost hundreds of thousands of dollars, and when you iterate, that cost just multiplies. Using additive manufacturing, which when you pair it with our material and the technology of Markforged, you are going to optimize your existing tooling with features that can only be produced on this machine. Period, exclamation point. You can freeform geometries, reduce stress, thermal constraints and cooling issues, and a lot more. With traditional techniques like casting or machining your tools, you're making them out of a solid block, right? It's not optimized. Here, you have the ability to create lattice structures, which help improve the overall strength of the tool, and at the same time, it reduces the cost because you're using less material. So when we think about all the different applications on the tooling side, I think about machining tools, jigs, fixtures on a CNC, assembling module fixtures or just assembling tools. What about molding tools for injection parts and hollow components, castings, and even machined robotic parts? There are so many tooling applications, and if you could just replace a small percentage of one of those on our machine, God, what could you do with all that extra time and money? You could put it towards your parts, put it towards the bottom line. So here are some use cases of some companies that are doing exactly that have taken advantage of Markforged and are really finding some success. Dixon Valve, obviously huge with Markforged. If you've done any research on their website, they are located down in Maryland, and they're a 100-year-old manufacturing company that supplies hose fittings and accessories. And Dixon's engineers, they bolted all potential vendor parts into one of their machines. It's actually a high-force robotic gripping system, and it's designed to maneuver almost about 110 pounds at high speed, and they just let them go to work. The Markforged parts were the only ones to survive that test. So now, printing prototypes and production tooling on a Markforged system for those guys, it dropped the lead time on tooling from 14 to 28 days down to only 1 to 3 days. Again, that's an incredible time saving. And on the money side, they saved $281 per part versus machining them out of aluminum. This printer practically paid for itself in 1.5 months. Another great example is GE. They are best in class for tooling. They need high strength parts. So when they produced their famous jet nozzle, they needed strong tooling to hold it in place for CMM and some laser markings. So they use the Markforged machine, and they actually use the onyx material to create a fixture for this application, because the huge advantage is that you're not going to scratch the end part. If you were to make that out of aluminum and that scratched that nozzle, then you would have to start back over again. And again, that's more time and that's more money. So the big thing here is that these fixtures are going to be very resilient. They're not going to scratch your parts. And lastly, there's a major automotive manufacturer that's a partner of Markforged, and they were really constantly fighting production line stoppages. When a car, the chassis actually came down onto the locator tabs, well, they're like pins that were made out of aluminum, they started to break. So an engineer got smart. You know, he got a Markforged machine, and he printed these out in onyx and reinforced them with fiberglass. And then he went to one section of the assembly line and he tested it out. Guess what? It held up, and it outperformed the aluminum part over a long period of time. Every station now for this company has a Markforged machine that produces these parts and anything else that they're going to need to keep those assembly lines running. Again, very impressive stories here. And these parts that are produced on these, phenomenal use cases, they're all printed on these machines, which we've come to know and love from Markforged. And this is just a quick breakdown of the composite machines that Markforged offered, up until now. You have your first generation Onyx series, again, printing just an Onyx with the build plate of the desktop series, which is about 12 by 5 by 6. And then you have the Onyx Pro, which again is going to add a fiberglass nozzle with the same build plate as the Onyx 1. And then you have your Mark II. This is their enterprise machine. It prints in all of the different types of material. So not only your Onyx filament, but the fibers we talked about earlier. You have the carbon fiber, the Kevlar, the fiberglass, and the high strength, high temperature fiberglass. And then finally, you have your Mark X, which they've now renamed the X7. And this really sets the bar for the industrial 3D printing world. It is the only industry sub 1 million in-part laser inspection, and this is going to give you layer by layer accuracy. Nobody else has this. But as we talk to our customers and they tell us what they want, we started to figure out that, well, there's a little bit of a gap there, right, between the Mark II and the now X7. The X7 makes beautiful end-use parts. There's no doubt about it. The surface finish on that is phenomenal. The parts are also 24 times stronger when you reinforce with carbon fiber, but it's also $70,000. We have companies that buy them and put thousands of hours on them. They even call other divisions of the company and they make sure they have one of those as well. $70,000 for a Fortune 50 company is super affordable and helps them get where they want to go. But what about everybody else? We've talked to so many businesses that would love to own the X7. It's got all the bells and the whistles to it, but really only need the bigger build volume or the higher resolution. And before, if you had a Mark II, you had to pay an extra $55K to get there. So what did Markforged do? They took their Mark X, which again is now renamed the X7, and they cut it in half to give you the X3. So the X3 is powered by the incredible material strength and stiffness of Onyx, which is that chopped carbon fiber nylon blend filament. So the X3 is printing strictly engineering grade thermoplastic filament parts. You're not going to be printing any fiberglass, carbon fiber, or Kevlar on this machine. So the major upgrades here are the bed size. You're going from a build volume of 12 by 5 by 6 inches with the desktop series to a build volume of 13 by 10 by 8 on your volume. So again, it's the exact same as the X7. You're also ramping up from 100 micron Z-layer resolution when you print an Onyx material to 50 micron layer resolution, for those parts that really need that quality finish. And then finally, you're getting the laser that's affixed on top of the print head. And this is going to level your bed and calibrate the machine before you print. This is huge in 3D printing because bed leveling is I believe, the single most important step in making sure your builds are accurate, right? With the desktop machines, you're using a shim-based manual lever, which is totally easy and streamlined, But again, the laser really fast tracks, that for you. So all of this package, a disruptive price of only $36,990. So if you guys have ever been to our office in Clark and seen the Mark X, it's a very similar body to that. I mean, it is an industrial grade performance machine. So it has an all aluminum unibody enclosure. It's built around an ultra flat gantry system, and they added machined aluminum stage with a pneumatic bed coupling and a precise ground print platform. It's really incredible. They really then closed the loop with the software by instrumenting each machine with a full sensor suite, including motor encoders and a calibrating laser, which again we just mentioned above, so accurate that it can compensate for a single-digit change in room temperature. So really, all in all, this is the new entry-level industrial 3D printer and fits perfectly into the market. This machine is already demonstrating demand from our existing customers, showcasing its place as not just a starter unit, but a high-performing machine, with a place in this manufacturing environment. All right. So here it is, placed into the industrial composite series. Again, everything to the left is the old desktop composite, still offering those machines, and everything to the right is the industrial new composite series. So as you can see, there's another gap there, right? So we know Markforged doesn't stop. They've been paying attention not just to what the customers want to see in their manufacturing processes, but in how those businesses operate. So they wanted to give their users a product that could produce parts 19 times stronger and 10 times stiffer than traditional plastics. So let me introduce the X5. This is the workhorse of the industrial line. They have the ability to reinforce an onyx part with a continuous strand of fiberglass. That is huge value, right? This has a very unique ability to deliver parts that are both ultra strong and affordable. And you're getting everything that we just talked about with the X3. You're getting the same build volume, 13 by 10 by 8. You're getting the 50 micron layer resolution when you use onyx material. Again, it prints in onyx. It also prints in the fiberglass material to make your parts strong. And again, it also has the built-in laser. And this price, again, it's 50 grand, right? That is the sweet spot in the market. I know I've talked to a lot of businesses that this is the budget that they have to spend, and they want the best machine out there. This is a great option. We're really excited about it. So here you go. This is both the X3 and the X5 placed into the industrial lineup. Again, the X7 still the baseline for really, really strong parts, best part finish, produces all of the materials, again, carbon fiber, Kevlar, fiberglass. But the thing that really stands out to us here, and I don't think anybody else does this across the board, any other company, they always make their printers upgradable, right? So if you can't start with the X7 at $70,000, start with the X3 or start with the X5. As people start to get more business and their needs, go up, they might not need the power right now to start at the X7. Markforged is going to give you an opportunity to upgrade as your power and your growth continues. So even the learning curve for 3D printing has come down substantially in the last couple of years. Not with Markforged. Markforged is a really, really very used machine, and the software is easy to use. Especially with our direct coaching. When you buy a machine through us, we're going to install it, we're going to train you on how to use it. You're going to be up and running in just hours after training. It's a really, really streamlined process. But if you're new to the industry, and many designers are, you're going to want to do more with it as you become more comfortable, right? So this is a great a way to give you guys options, and incorporating these upgrades. And at the end of the day, we just want you guys to be happy, with your purchase and still have the ability to invest in other things that will allow you to grow your business. So these upgrades take a lot of the anxiety away from making a $37,000 purchase. You want the strength of it. I know you want the materials and the resolution, but you just don't know yet if you want to spend $70K. I get it. This offering gives you a bunch of options to eventually get there. So before we wrap things up, I do want to, talk just a little bit about metal. We're going to have another webinar here within the next month or so to talk about the Metal X. We know it's here. We've seen the sample parts. It's incredibly exciting in the industry. It's Markforged's 4th generation machine, which is going to print, 2-day, sometimes same-day metal parts. It's a very similar process to metal injection molding, if you guys are familiar with that. So printing a metal powder bound in a plastic matrix or a binding material, and then what you're going to do is you're going to wash the part, get rid of excess, resin, and then sinter that part into a furnace. And by doing this, you're going to eliminate a lot of the safety risks associated with traditional metal printing. If anybody on this call has ever been a part of that or currently owns one. And that's how you're going to get your 99.7 dense part is by doing that in a sintering oven compared to having a laser built into the machine, which is your SLS technology, and you have to pay $500 million to get there. This machine is really office friendly. You can put the machine itself again in a normal work environment. The post-processing equipment that comes with it is a little different. We can talk about that later on, but really importantly, you just have so many new features and ways that you can innovate and build parts on this machine. For example, like the ability to use closed cell infill, for reduced part weight and cost. Where else can you do that? So right now they're shipping product in September, and the material will be 17.4 stainless steel. They're also going to be releasing 316L. Titanium, aluminum, tool steel, Inconel, and I'm sure more and more as more requests come in. So, all in all, they're going to give you everything you need to go from design to fully functional metal parts. That's no doubt about it. We're really impressed with what they have to offer and can't wait to get our hands on our own machine. So we have a bunch of metal parts. So feel free to sign up for one of our open houses. Come by, check it out. I'd love to learn more about your business. You can go to our website, our events page, and sign up, or email me directly with any questions that you guys have. If you want to schedule a facility visit, I do quite a few of those, each week. So really, before we wrap this up, I'm going to give it over to Alex. Markforged, again, a really impressive company for us. They really remain focused on its mission to make 3D printing a stronger and less expensive option for manufacturing. And I hope everybody is as excited as we are about this new product and Markforged. And we look forward to continuing to help educate you guys on this topic and be there as your go-to reseller for 3D printing and software. So that's it. Alex, I'll go ahead and open it up to you. I know people have been sending you some questions, so I'll leave it up to you.
All right, thank you so much, and great presentation. I'm always happy to help. So yeah, we got a couple questions in over the course of the presentation. One of them was, what level of detail can you achieve with the different printers? So in terms of because the print gets built up layer by layer, the XY resolution of all the printers is plus or minus about 50 micron. And then on the industrial series, we have the 50 micron in Z, so a very finely detailed resolution for the Z-axis. And on the desktop series, so the lower line, we have 100 microns. So the industrial series gives you higher fidelity, higher resolution in your parts, and you get very, very smooth, very polished parts. We had a couple. I'm going to focus on mostly the industrial series questions for now, and then there were some metal questions that also came in that I'll get to later. What is the difference in the laser utilities between the different products in the industrial lineup? So with the X3 and the X5, the laser is used as a calibration tool. So essentially what that means is it will scan your print bed to essentially get a very, very highly detailed contour map of the print bed. And that way it can ensure that it prints, a perfect first layer every time. So it essentially uses that laser to calibrate the printer settings so that your print ends up succeeding and being very, very polished. One of the one of the issues that we saw in a lot of other 3D printers on the market was that, and that occurs in 3D printing a lot, is that usually the most common failure mode of a 3D print occurs within the first few layers. And so what the laser allows us to do is ensure that those first few layers will be perfect. And thus the X3 and the X5, as well as the X7, essentially generate a contour map of the print bed to ensure that we're getting a perfect first layer every time. And it compensates for that as it builds up the print. The X7 has some more advanced utilities using the laser. So the X7 has what we call in-process inspection. So you can elect to scan your part mid-print to verify that you're hitting the critical dimensional tolerances that you want in your part. So say you really care about a very specific feature within your part, and the print, if it's a very long print, you have heavy fiber reinforcement or something like that, it may take a couple days. With the laser inspection utility, what you can say is, this critical feature is something that I really care about. And you can go in, and as the printer is printing, it can scan that feature for you. You can inspect that in our software package, and it will tell you, and basically you can measure it and see, is this hitting the tolerances that I need to? And that way you can essentially, it enables sort of a in-process quality assurance check. So if the print is if the print is out of specification, you save a lot of time, a lot of materials by enabling this sort of inspection functionality to ensure that your prints are coming out just the way that you want them. Another question came in about materials. Can you describe the difference in use case applications of the different fiber materials? So as Charles showed in the graph earlier, we have 4 different fibers that we work with: Kevlar, fiberglass, carbon fiber, and high strength, high temperature fiberglass. So the fiberglass, which you can print with on the X5, is sort of our workhorse material. It gives you very robust, very sturdy parts. So a lot of companies, a lot of industries will use parts reinforced with fiberglass for things like soft jaws, tooling and fixturing for CNC machines, welding fixtures, things like that. The carbon fiber, which is available with the X7, the continuous carbon fiber, is where lightweight, high stiffness, high strength is really valued. So if you are working on an end effector for a robotic arm, for example, and you want to maximize your production throughput of that machine, because carbon fiber is very, very stiff but very, very lightweight and has a high strength to weight ratio, you can make your gripper jaws, your end effectors on your robotic arm extremely lightweight. That will allow you to make your robotic arm faster because it's carrying less weight overall, and maintain that strength, that stiffness of something like of metal, with our carbon fiber reinforcement, we can get parts that are comparable to aluminum. And so where you really need that lightweight, high stiffness, high strength is where the carbon fiber comes in. And then our 2 other materials that we offer with the X7 are, they include Kevlar. So Kevlar is a very shock absorbing material. If you are working with parts that undergo a lot of intermittent loading, that get loaded repeatedly and repeatedly, and you need them to absorb and hold under a lot of those loading scenarios with minimal deflection. So the Kevlar will essentially act as like a shock absorber. And the high strength, high temperature fiberglass is one of our other materials that is offered with the X7, and that essentially is for printed parts that need a higher heat deflection temperature if you are working in higher temperature applications, if your parts are going to be used as such. A few questions came in about metal. So one of the questions was, can we make mold and die tools with your metal printers? So that's absolutely one of the applications that we expect to see with our metal printers. We basically what happens with the metal printers is that once your part is printed and goes the post-processing and sintering steps, you get basically you can expect it to behave as if it were the original raw material itself. So in applications where tooling, where dies are used traditionally, you can definitely use the metal printer to manufacture some of those parts because the final metal part is will behave just as the raw material would. And then another question was about, can the industrial series print metal? So the industrial series is limited to the composite materials and the fiber reinforcement materials, and the metal printer is a separate product that Markforged has created called the Metal X. And so there are two distinct product lineups, but that serve sort of different material needs. And that's all the questions we got. If there are any more, please let me know, or feel free to reach out to DesignPoint or out to us if you have anything else.
Great. Thanks so much, Alex, for tuning in and answering those questions. Again, I hope everybody learned a lot about Markforged today and what they have to offer. Feel free to, again, email me or give me a call, and we'd be happy to chat more about the education of this product line. But again, thanks for coming out, and have a great day.